Hello and welcome to GCSE Chemical Changes with Mrs. Castanera. We're on lesson 6, metals and acid. Today's key words are hydrochloric acids, hydrogen ions and redox. So we're going to start by completing the knowledge check on page 41 of the booklet. There are 8 questions. Please pause the video whilst you answer those. So let's go through those. Question 1. Explain why water is a polar molecule. That's because there are 2 oppositely charged poles or sides. Question 2. Describe the relationship between opposite poles. Well, opposite poles attract each other. Question 3. State the 2 ions that water dissociates into. That's H plus and OH minus. Or you may have put hydrogen and hydroxide if you've written it in words. Question 4. Name the structure that ionic compounds can form. That would be giant ionic lattices. Question 5. Name the bond between water molecules. Hydrogen bonds. Question 6. Name the ion common in all acids, H+. Question 7. Name the scale used to measure the concentration of an acid. It's the pH scale, and that's a lowercase p and a capitalised H. Question 8. Name the 3 common acids used in GCSE science. So HCl, that's hydrochloric acid, NHO3, nitric acid, and H2SO4, sulfuric acid. You could write that as the symbols or the words. Either is fine, you do not need both. But if you're not sure which one's which, do identify them with words, please. So give yourself a mark out of 8, or in fact 10, that's 1 for each acid. Give yourself a mark out of 10. So today's overview of today's lesson, we're going to be able to, at the end of this lesson, explain in terms of gain or loss of electrons that these are redox reactions. So metals and acids are redox reactions, and you'll be able to explain that in terms of the loss or gain of electrons. You will also be able to identify which species are oxidized and which are reduced in given chemical equations. So moving on to reacting metals and acids. Some metals react with some acids to produce salts and hydrogen. So metals, acids produces salt and hydrogen. Now it's not all metals and not all acids will react. The name of the salt depends on the name of the metal and the acid that is used. So when naming a salt, the first part of the name is derived from the metal. So the first part of the name is based on the metal that's used, and the second part of the name derives from the acid. So for hydrochloric acid, it's metal chloride. For nitric acid, it's metal nitrate, and for sulfuric acid, it's metal sulfate. So any metal with hydrochloric acid produces metal chloride, any metal with nitric acid produces metal nitrate, and any metal with sulfuric acid would produce metal sulfate if they react, and not all will react. So there's some videos to watch. There are 2 of them to learn more about making salts. So if you have a digital copy of this booklet, you'll be able to click on these links to go to them. If not, feel free to go to YouTube, to the YouTube website, and look for the Fuse School channel, and type in water salts and acid plus metal, or you can just type in Fuse School water salts and then Fuse School acid plus metal, and those will take you to the correct videos. Fuse School is an organisation that produces these videos, and they're very helpful. So pause the video whilst you watch those. So hopefully watching those videos has improved your understanding of the reactions between metals and acids, what salts are, and how we make salts. So we're going to move on. We use something called state symbols, which we have briefly looked at before, and they show what state each substance is in. So to represent a solid, we use a lowercase s in brackets, a liquid is a lowercase l in brackets, a gas is a lowercase g in acids, and aqueous is lowercase aq in acids. And aqueous means dissolved in water. So if I had some salts, some sodium chloride dissolved in water, that would be an aqueous solution. If I had solid sodium chloride, that would be a solid. So here we have an example of that. So we have our metal and our reacting with our acid, producing a salt and hydrogen. So in this example, our metal is magnesium, the acid is hydrochloric acid, and we know we'll get metal chloride, so it's magnesium chloride, and it also produces hydrogen gas. And here below that, we have got the same equation written in chemical symbols in formula. So Mg for magnesium, capital M, lowercase g, with brackets S to represent that it is a solid. Then we've balanced it, so we've written 2 lots of hydrochloric acid, HCl, and in brackets we've written that is AQ because the hydrochloric acid is dissolved in water. Acids need to be dissolved in water, otherwise the hydrogen ions are not released, and therefore it's not acidic. Then salts, we have magnesium chloride, MgCl2, again aqueous. And lastly, we have hydrogen, H2, which is gas, so that's just a hydrogen gas which will bubble off into the atmosphere unless we capture it. When writing out equations in future, you'll be expected to identify whether these materials are solid, liquid, gas, or dissolved. If there's an acid involved, it will almost always be aqueous. If it's a salt and it's reacting, then it will need to be dissolved in water as well, so that will be aqueous too. So we're now going to look at the redox reaction, or the redox aspect of metal and acid reactions. So when a metal and a acid react, it is a redox reaction. And a redox reaction, to remind you, is when reduction and oxidation happen at the same time in a reaction. So that means that one substance gains electrons or loses oxygen, and another substance loses electrons or gains oxygen. So in the example from the previous page, we can see a redox reaction between the magnesium and the hydrogen. Now the chloride ions don't change. The magnesium atoms lost their electrons to become magnesium ions. And that's shown here in this equation. So the magnesium here, it has lost electrons to become magnesium ions here. MgCl2 dissolved in water, aqueous solution because it's dissolved in water. So the magnesium atoms have lost their electrons. Now here we have the hydrochloric acid, and the hydrogen ions have gained electrons to become hydrogen atoms, as shown by this arrow here. So you can see here the 2 different things, and I've put them in different colours to show how they've changed. So remembering our acronym oil rig, oxidation is loss of electrons, reduction is gain of electrons, and we're going to write that here. Okay, so if this has lost electrons, oxidation is loss of electrons. So the magnesium was oxidized. So oxidation has occurred here. And the hydrogen ions have gained electrons, so reduction is gain of electrons. So this one is reduction. Now only higher tier students would need to be able to identify this by the electrons. If you're a foundation tier student, you'd only be expected to know whether it's lost or gained oxygen to identify whether this is reduction or oxidation. So you wouldn't need to identify where oxidation and reduction occurred if you're a foundation tier student in this example. So I'm just going to put here that this is a higher tier example. Okay, so I'm going to move on. So the hydrogen atoms do not like to exist as single atoms because their outer shell is incomplete. Okay, so hydrogen atoms, they only have 1 electron in their outer shell, so they don't like to exist as single atoms. That's because their outer shell is complete. So they bond covalently to each other to form hydrogen molecules, H2. I'm going to write a little note about that. So I've made a note here to say that they only have 1 valence outer electron, they being the hydrogen atoms, and this shows that what they do is they share their electrons with each other to have 1 shared electron pair. So I don't know if you can see this very well, but I've written around this one in green, and it's got a green cross to represent its electron, and this hydrogen atom's written in red, and it's got a red cross to show its electron, and they're sharing that as an electron pair. So if you could write that out and draw that little diagram, that'd be wonderful. So to learn more about electron exchange in the oxidation reduction reactions as discussed with metals and acids, there's a video to watch here. It's another Fuse School video, And you can click on the link if you have a digital copy of this booklet, or you can just go to YouTube and type in Fuse School Electron Exchange and Oxidation Reduction Reactions. Make sure you write it out exactly as it is, because this is literally the title from the video. So pause the video whilst you watch that. So we're going to look at concentrated and dilute acids now. So concentration tells us how much of a substance there is dissolved in the water. More concentrated acids have lots of acid and a small volume of water. Less concentrated acids, that's a dilute acid, have little acid in a large volume of water. So that's about dilution. Okay, so dilution is essentially how much water you add to it. Same way you get squash. You can get squash straight out of the bottle. It's very concentrated, very strong. It tastes very icky because it's too much. Whereas if you add water to it, you dilute it, and there is less of that squash, that flavouring, and it tastes better to us. And you could dilute it too much, and then it doesn't taste great either. It's a bit like acids. You can dilute them with water, and so if there's too much of the acid, it's very dangerous. Dilute it with water to a bit, and it'll form a useful concentration of acid. If you continue to dilute it, it becomes very weak, and those are the kinds of acids that we would then find in things like foods that we eat. Also less useful when they're low, very dilute acids. So in the space below, draw an annotated diagram to show the differences between a dilute strong acid, a dilute weak acid, and a concentrated strong acid and a concentrated weak acid. So first of all, we're going to review what the difference is between a strong and a weak acid. So just having a quick look back to last lesson, we've got here an example about acids. So we have our three acids, hydrochloric, nitric and sulfuric. And this shows us the positive hydrogen ions, which make it acidic, that are released when they're dissolved in water, and the negative ions that are released when they're dissolved in water. And remember that sulfuric acid is twice as strong because it releases twice as many hydrogen ions compared to nitric and hydrochloric acid. So we're going to show that in a diagram. So what I've done here is along the top I'm showing a weak acid, which is hydrochloric acid in this instance. It has one positive for every negative ion that's produced. So one hydrogen ion, which is the acidic part, for every chloride ion. Now a strong acid, like sulfuric acid, produces two hydrogen ions for every sulfuric part, for every sulfate ion. So let's show that a bit more clearly. Okay, so you can see that what I've done here is I've put two lots of each of these acids in, and you can see that there are two hydrogen ions, the acidic part, in the weak acid, but there are twice as many of these hydrogen ions that make it acidic in the strong acid. Now, this is just an example of standard weak and strong acid. Now, remember that these are all dissolved into water, so this background behind these is all water. So let's add an annotation. So as you can see, I've literally just written into the box that they're dissolved in water because I don't want to complicate things by showing the water molecules or ions. So now we're going to look at what it might look like if we diluted those strong and weak acids and if we concentrated those strong and weak acids. So I'm going to draw the boxes that I want you to draw, and then we'll all go through that together. So as you can see, I've drawn this table here, and we've got our strong acid. I want you to continue this along the bottom, and we've got our weak acid, and I want you to continue that along the top row. And so what I want you to do is, in this one, I want you to think about what it would look like if you got up really close to it when you had diluted this weak acid. So you take this picture here, and you essentially add more water. Okay, now remember it's the same size box. What's this going to look like in a diluted example? Then what's it going to look like if you concentrated it? So less water, more acid. Okay, what's it going to look like then? Same goes for the strong acid. How would that look if we diluted it? And how would it look if we concentrated it? So have a go at drawing those. I recommend you draw in pencil. Don't add any colour yet, so that you can check your work before you complete it in pen or add anything that you can't erase. So pause the video whilst you have a go at that activity, please. So hopefully you ended up producing a diagram looking a little bit like this. So when we take our weak acid, which we had 2 hydrogen ions and 2 chloride ions dissolved in water, and we diluted it, we had less hydrogen ions, so I've just put 1 in, and less chloride ions. And you could add that there is more water or more space for water. And then when we concentrated our weak acid, there would be more of the positive ions and less of the negative ions. So I had made a slight mistake there, which I've corrected by changing this one. So this time there are more hydrogen ions, so there were 2 of them, and now there's 3, and more chloride ions, so there were 2 of those, and now there's 3 of those. So this time there is less water, or less space for water. Now we're looking at the strong acid. So there were, remembering a strong acid has twice as many, in this case, twice as many hydrogen ions as there are negative ions. So again, when we dilute it, we've still got twice as many of the positive hydrogen ions to the negative ion, but there is now more water, and there's only half the amount from the strong acid. So we've doubled the amount of water or half the amount of acid. And when we concentrate it, it's 50% more concentrated. So there is an extra 50% more. So we had 4 hydrogen ions, and now there are 6 positive hydrogen ions. And we had 2 negative ions, and now we have 3 negative ions. And the ratio of 2 hydrogen ions to every negative sulfate ion is still there. So you can see that they're the correct ratio. And again, there is less water. Okay, or just more acid. So make sure you've got that correct and give yourself a mark for each one that you got correct. So let's mark out of 4, please. But most importantly, make sure you've got that diagram drawn out correctly. So pause the video if you need to do that to get this drawn out. So we're moving on to page 43 in the booklet now, and we are looking at forming and naming salts. So complete the spaces in the tables below by performing the reactions. Now we can't perform the reactions, however, you can use what you have learnt, which is that a metal with an acid reacts together to produce a salt and hydrogen. And you know that the name of the salt is the metal, and then the important part of the acid, so for instance hydrochloric acid, it makes it magnesium chloride, so metal chloride for chloric acid, or metal sulfate for metal with a sulfuric acid, or metal nitrate with when you react a metal with a nitric acid. Okay. You will also be required to write the symbols and balance each of these equations correctly, and don't forget to add in the state symbols as required. So remember that AQ means dissolved in water, S for solid, L for liquid, and G for gas. Remembering that the acid and the salt are both going to be aqueous because they are always going to be dissolved in water when we're reacting in this way. So pause the video whilst you attempt those questions. If you're not sure, please feel free to pause the video, just do one question, and then check your answer and keep doing that. So pause the video now. So let's go through those. So the first one was magnesium plus sulfuric acid, and that will create magnesium sulfate. So give yourself a tick if you got that correct, and that one is a mark out of 1. Then the next one is magnesium and nitric acid, which gives us magnesium nitrate. So this one is also just another mark, 1. The third one, there are 2 things to get. So zinc, the symbol for that is a capital Z, lowercase n. So you have a mark for the symbol correct and a mark for the states symbol, which is a small s in brackets. And zinc and hydrochloric acid make zinc chloride. So you can have 3 marks for this one. So the next question is also zinc. So 1 mark for writing that zinc. And H2SO4 is sulfuric acid, so you get a mark for that. And zinc and sulfuric acid form zinc sulfate. So again, this one is out of 3. The next one is iron, which is Fe, so you get a mark for the correct symbol and a mark for the bracket with lowercase s to represent the iron as solid. And then it produces iron chloride because it's hydrochloric acid. And the symbols for that is FeCl2, capital F, lowercase e, capital C, lowercase l, subscript 2. It needs to have the correct capitals and lowercases. And that is an aqueous, so it's dissolved in water, so you can have a mark for in brackets writing AQ. So this one is out of 5. And finally, this one could have left you guessing. So I'm letting you know now that this one is iron. So have a go at this question using iron as the metal, please. You'll need to pause it again just to have a go at the last one, please. So this last one is a real tricky one because not only did we not tell you what the metal was, it wrote in hydrochloric acid for the symbols for sulfuric acid, which was not correct. So it should be H2SO4 and in brackets aqueous. So if you wrote that, 2 points. In fact, I'll give you a third for being so smart and so clever for noticing it. If you didn't notice that, have another go at this question, okay? So iron is Fe, you have a mark for that, and a lowercase s in brackets, and then it produces iron sulfate, so you have a mark for that, and that is FeSO4, so a mark for the correct symbol. So Fe is capital F, lowercase e, capital S, capital O, lowercase 4, and, subscript 4. And then aqueous, AQ, lowercase in brackets there. So there's quite a lot here. So that's 8 marks available for this one. Don't worry if you got this one wrong because there was so many issues with it to start with. So if you want to give yourself a mark out of... So it's supposed to be a mark out of 21. Tell you what, because there were so many issues with this one, give yourself a mark out of 20. If you got an extra mark, you can just have that as a bonus mark because there were so many issues with this. So give yourself a mark out of 20 here. So moving on to page 44, testing for hydrogen gas. And this is a really important test you need to know. So a positive test, that means the hydrogen gas is present, for hydrogen gas is a squeaky pop when you light it using a flame. And the way this works is you get a test tube which you think has the gas hydrogen in it. You put in a lit splint, so it's a bit of wood that you light, and you put it into the test tube. And if it makes a squeaky pop sound, like a high-pitched squeaking noise, when it goes in, then that is a positive test and it is hydrogen gas. If it doesn't do that, then it's a different gas that you have got. So moving on, why are salts useful? Well, the most common salt, sodium chloride, and I'll give you the symbols for that, NaCl, capital N, lowercase a, capital C, lowercase l. Sodium chloride has many uses. So we use it for flavouring, in particular for food. So when you add some salt to your chips or a bit of salt to perhaps your vegetables and that's part of the flavouring. Restaurants use it in particular. We also use it for food preservation. So particularly when we didn't have fridges several hundred years, 100 years ago, we used salt to salt meats and other things that were savoury that would go off otherwise without the salt to preserve it. Salt makes it hard for bacteria to multiply, preserving the food. We also use salt for making chlorine gas, very useful for swimming pools. We use salts in medicine, so if you get dehydrated or you have a nasty injury where you lose some blood, quite often before they even give you blood, they will give you a saline drip. And a saline drip is sodium chloride mixed into water, so it's a salt solution. We also use sodium chloride as salt to thaw the icy roads. So when they grit the roads, that's sodium chloride in the form of rock salt, which is a mixture of rock and sodium chloride. We also use it as part of our cleaning, so it's found in various cleaners. So we use salts as well to make products such as fertilizers. Okay, so we're going to move on to the checkpoint question. The pH of a weak acid is always higher than the pH of a strong acid. So this is the statement. The pH of a weak acid is always higher than the pH of a strong acid. Evaluate this statement. So this is a 6-mark question, and that's really, really important to notice, because if you say, yes, this is correct, or no, this is not correct, that's not going to get you 6 marks, okay? So you're going to need to say, yes, this is correct, no, this is not correct, and why. And the why needs to be 6 marks worth of why. So that's a lot of things to be saying there. So you say multiple things to explain why this is a correct or incorrect statement, please. So pause the video whilst you have a go at this checkpoint question. So let's go through that. So there's a number of things that you could say. There are 6 statements that all could be good answers for this. So first of all, if you said something along the lines of pH measures the concentration of H plus or hydrogen ions, you can have a mark for that statement. Now, if you've said that the greater the concentration of hydrogen ions, the lower the pH, or the opposite statement, so a low pH is a high concentration of H plus ions, or a high pH is a low concentration of H plus ions, anything along those lines, then you can have a mark for that. You could also say that for weak and strong acids of the same concentration, diluted with the same amount of water, the H plus ion concentration will always be smaller in the weak acid, so that the pH will be higher. You could also say if they're the same concentration, the H ion concentration or the pH will be higher in the weak acid. So next you can say that, so the statement at the top of the checkpoint questions, the question statement is true, but only for solutions of the same concentration. So if you've written that, you can have another mark. Now, you might have said that actually you could dilute a strong acid so much that it would have less hydrogen ions than a concentrated version of a weak acid, because pH is all about the amount of H plus ions, not about whether it's a strong or weak acid. So you can have a mark for that. And that leads us to this final statement, that the statement at the top of the question is not always true for solutions when they have different concentrations of their acids. So different concentrations of solution will mean that the statement is not always true. Now, this was a really tricky question. I say this is a very high level question. I'm going to zoom out. So as I said, this is a really hard question, okay? It's quite a high level question, and I wouldn't expect many students to do really well on this the first time around, which is why we practice in these lessons. So make sure that you have written out each of these statements and that you understand them as well. And so that if you got this question again, you'd be able to write out a better answer and get more marks for it. Now, if there's anything you don't understand here, do please ask your science teacher if you're in school, or email myself or whoever it is that's currently teaching you, and we'd be very happy to explain this and go through this in more detail. So give yourself a mark out of 6 for this question, please. So we're just going to move on to the knowledge check on page 44. There are 8 questions here. Please pause the video whilst you answer the questions. Okay, let's go through those. Question 1. Metal plus acid makes a salt plus hydrogen. The salt formed from hydrochloric acid and iron is iron chloride, or FeCl2. The salt formed from sulfuric acid and magnesium is magnesium sulfate, or MgSO4. Question 4. The salt formed from nitric acid and zinc is zinc nitrate, Zn open brackets NO3 close brackets 2. Either the words or the formula is acceptable. You don't need both. Question 5. The salt formed from hydrochloric acid and calcium is calcium chloride, CaCl2. The substance oxidized in question 3 was the magnesium, and the substance that was reduced in question 5 was the hydrogen ions. And the uses of sodium chloride include flavouring, food preservation, making chlorine gas, medicine, thawing icy roads, cleaning, and making fertilizers. So give yourself a mark out of 10, because there are 3 marks available for this one. So you have up to 3 uses there. So mark out of 10 for that, please. Moving on to the application of knowledge question, a chemical manufacturer wanted to make some copper sulfate, suggest the reactants for this reaction, and predict the products. So pause the video whilst you have a go at that question. So let's go through that. So the reactants for this reaction would be copper and sulfuric acid, and the products would be copper sulfate and hydrogen. And I've written this out in both words and using the chemical formula and the state symbols. So this reaction is balanced in this way. So if you've written out the reactants in words, you can have a mark. And if you've written the products in words, you can have a mark. You need to get both of the reactants and both of the products for each of the marks. Then, if you have written each of these individually correctly, you can have the mark. So if you've written Cu for copper and said that it's a solid, you can have a mark. H2SO4 for sulfuric acid and that it's aqueous, you can have a mark. You need both of them for the mark. CuSO4 for copper sulfate and the fact that it's aqueous, AQ in brackets, that's another mark. And H2 for hydrogen and in brackets that it's a gas for a fourth, well, another mark. So that is out of 6 there. If there's anything you haven't got, make sure you write it down, please. So we're going to move on to the extension activity. Explain why sulfuric acid is considered more dangerous to use than hydrochloric acid. As a hint, you should look at the chemical formula for each and the number of hydrogen ions dissociated. And we have looked at this in the past. Okay, so you should be able to do that. And we won't go through that because it has been discussed and written about in the lesson. So finally, before we go, you will need to learn the keywords and definition, please. And you need to be able to give a good example of the definition when you're asked to from the keyword, or using the definition, explain what keyword this is. Thank you very much. If you have any questions, please ask your teacher and we'll be very happy to help.